Once again, good morning and welcome to our general mathematics class. Today we'll have lesson 2.3 and it's about rational inequalities. To start with, our memory verse is found in Romans 2 verse 11. It says, "For God does not show favoritism." Your MVCA boosters today is centered on the inequality at Egypt. The book of Genesis ended with Joseph and his family staying in Egypt. However, the book of Exodus started telling us the story of the inequality that happened in Egypt. You need to read Exodus 1, verses 8 to 10, and you share to us what were the reasons for this inequality. Now, at the end of today's class, you'll be able to do two things. First, solving rational inequalities. And second, we'll solve problems involving rational inequalities. I'll skip the venture part this time so we can maximize the time for your quiz at 9:30. Now, we'll ask, what is a rational inequality? We go back to the definition for rational expressions. Remember, it's a rational function when the numerator and denominator are both polynomials. Now, if you have the inequality sign, like the less than or equal to, greater than or equal to, less than and greater than, and there are rational expressions, then we call that rational inequality. Here are some examples. It can be one rational expression on the left, one on the right, with the inequality sign. That's a rational inequality. Or it can be like the second one, or the third one, like one expression and another rational expression, another integer on the right, and an inequality sign. It's still called a rational inequality. Now, how do we solve rational inequalities? I made this acronym so you can find it in other books, but it's for you to remember the steps, the 5 steps easily. I name it the Smuth Method. S stands for single rational expression. Now, you know that you have a good start if on one side, on the left side, hand side of the inequality, you have a single rational expression. Like, for example, x over 4, just one. And the right-hand side, you have a 0. Ma'am, what if it's not yet in this format? Like example, you have x over 4 greater than 3. It's not 0 on the other side. Then you need to transfer 3 to the other side and write it as a single rational expression. This example is not in the first step yet. If you'll see, your left-hand side has a binomial. It must only be a monomial, one rational expression. Now, the second one is meaningful numbers. We need to find the meaningful numbers of both the numerator and the denominator. How are we going to do that? The numerator, you equate it to 0. Denominator, you also equate it to 0. Then you solve for the value of its variables. After that, you need to substitute the meaningful number again to check if the number is a part of a solution or not. If it's a part of a solution, then we shade it with the circle will be shaded in step 3. But if it's not part of the solution, then we do not shade the circle. That's for the U. We use the meaningful numbers to plot the number line. Example, if your meaningful numbers are 3 and 1, then we need to plot it in a number line. You can just have both numbers, 1 and 3. Then again, if it's a part of the solution, shade the circle. If it's not, then remain the circle unshaded. Next, test T, test the values. We divide the number line into 3 parts, or for some 2 or for some 4. How do we divide it? We base it in our meaningful numbers. Example, in this number line, we only have 2 meaningful numbers. So we can divide the number line to the one before 1, between 1 and 3, and after 3. Then we find a number for each interval. Substitute it to our main inequality, and then we check if it's true or false. Then the last one is E, express. Express the answer in interval notation. Remember that the arrow on the left is your negative infinity, while the arrow on the right is your infinity. When we write answers in interval notation, parentheses will always go with symbols for infinity, while brackets are used for symbols with equal to, like less than or equal to, or greater than or equal to, while parentheses are used for symbols for less than and greater than. Again, the Smuth method. S, single rational expression. M, meaningful numbers. U, use the meaningful numbers to plot the number line. T, test values. And E, express your answer in interval notation. Let's have 3 sample problems for this morning. Let's start with the first one. Now you check. The left-hand side is already in a single rational expression. The right-hand side is in 0. So it's a go. So we copy that for our step 1. 1 over x plus 1 less than 0. That's it, because it's already in a single rational expression. Second, meaningful numbers. Let's start with the numerator. For the numerator, 1, there's no variable, so just copy. 1 greater than 0. It's not okay, right? There's no variable, so we don't have any meaningful number. It's a false. Next, let's go to our denominator. For our denominator, we need to equate it to 0. So x plus 1 is equal to 0. Solve for the value of x. X is equal to negative 1. So our meaningful number is negative 1. But then, after you solve for the meaningful number, we need to substitute it to our inequality. So substituting negative 1, we have 1 over x plus 1 greater than 0. 1 over negative 1 plus 1 is greater than 0. If you see, our denominator is 0. So it becomes undefined. If you have the undefined, it means it's a false. What do you mean by false? False means it's not a part of the solution. So our circle will be unshaded. Let's have you use the meaningful numbers. We only have one meaningful number, right? It's at -1. It's false, so we remain the circle unshaded. If it's true, then you can shade the circle. Now, remember -1. Our number line is divided into two areas, before -1 and after -1. So let's go to step number 4, test values. Remember, our first is before -1. The other is after -1. Now we need to find a test value or a number before -1. So example, we have -2, right? -2 is found here. So it's okay. For the after one, we need to find another number for after -1. Example, we can have 0 because 0 is found in this area. So after, the after interval. Next, we need to substitute our test value to our original inequality. So let's have 1 over x, -2 plus 1. Let me just solve on the right-hand side first. So 1 over -1, the answer is -1, greater than 0. Now, based on your answer, you need to analyze if it's true or false. -1 greater than 0. Is it true or false? It's false, right? Because it's less than 0. Then the next one, after, let's have our test value is 0. Let's substitute 0 to the value of x. We have 1 over 0 plus 1. I'll be working on the right-hand side first. We have 1 over 1. That is 1 greater than 0. 1 is greater than 0. That is a true. So now, how will I know what's the final answer? You just darken the shade of the true remarks. So it's after -1. So this one, right? So this will be our answer. How will you write it in interval notation? Here, the first number is -1 to positive infinity. Let's go back to this one. Remember, for infinity, the parenthesis will go with it. So we'll write a parenthesis on, we are going to write a parenthesis on our infinity. -1 is not included. So we just write a parenthesis. Again, for unshaded circles, you can have a parenthesis. But for shaded circles, it must be a bracket. Any questions? Before I'll go to the second example. No other questions? Feel free to raise your hand if you have questions, okay? Let's go to the second example. For the second example, you check on your left-hand side again. Yes, Mark. Question?
Kanang sa fraction man ba kung ang numerator 0 undefined gyapon na man no?
No. For example, if the numerator is 0, let me give you an example. 0/5, the answer is 0. It's not undefined.
Salamat ma'am.
Okay, you're welcome. Again, it's only undefined when the denominator is a 0. That makes it undefined. Let's go to the next one. If you'll check in example number 2, the left-hand side is already a single rational expression, and the right-hand side is a 0. So it's a go. We write it as a single rational expression. That's x plus 2 over x minus 3 less than 0. Oh, that's good. Next, we will have our meaningful numbers. Let's start with the numerator first. X plus 2 is equal to 0. Transfer to the other side, x equals -2. That's our first meaningful number. Let's substitute it to the inequality. -2 plus 2 over -2 minus 3. I'm working on the left-hand side. That's 0 over -5. That will be 0. 0 divided by any number, the answer is 0. 0, sorry, I forgot the equal to. 0 is less than or equal to 0. If we only have the less than sign, it's a false. But since we have the equal to, then it's a true. The next one, denominator. X minus 3 equals 0. We do transposition, so x equals 3. That's our second meaningful number. We substitute it. Let me give you a hint. Actually, when you substitute the denominator, the answer will always become undefined. Like this one. This becomes 0, right? So the answer becomes undefined for the denominator. So it's always false. Now we plot our meaningful numbers. What are the numbers? -2 and 3. You can just have two numbers. Let's draw the circle. -2 is a true. Therefore, we'll have a shaded circle. It means it's a part of the solution. For 3, it's false. So it remains open. Open, or we say unshaded. Now remember that one, -2 and 3. Let's go to step number 4. -2 is shaded. Okay, now we have 3 parts. First part, second part, and the last part. Now here, we have before -2. What's the second part? Between. It means between -2 and 3. And the last is after -3. Now, we check on this. Before -2, our test value can be -3. Between -2 and 3, ma'am, can it be any number? Yes, actually it can be any number as long as it's within the interval. It can be a fraction, no problem, as long as it's within the interval. The answer, the remarks, will always be the same. For after +3, we have 4. So let's now substitute. I'll be working on the right-hand side. We have -3 plus 2 over negative 3 minus 3. We have negative 1 over negative 6. That's 1/6 less than or equal to 0. 1/6 is less than or equal to 0. This is a false. How about the between? The between, let's have 0. I'll be working on the right-hand side. So you have 0 plus 2 over 0 minus 3. We have 2 over negative 3. That is negative 2/3. Is negative 2/3 less than or equal to 0? It now becomes a true. The next one, 4. Okay, I'll be working on the right-hand side. 4, you have 4 plus 2 over 4 minus 3. Less than or equal to 0. Now, working on the right-hand side, we have 6 over 1. Less than or equal to 0. So that will be 6 less than or equal to 0. Let's check. It is a false. Now, I told you that you only mark the one with a true. And that's only between negative 2 and 3. So we darken it here. That is the only answer. Now, how will I write the answer in interval notation? We have from negative 2 to 3 only. Now, negative 2 is a shaded circle. So we have a bracket. 3 is an open, unshaded circle. So we have the parenthesis. Any questions? No other questions? Let's go to the last example. Here. If you'll check, the left-hand side is a single rational expression, but the right-hand side is not 0. So we need to transfer 4 to the other side. So we have x plus 2 over x minus 4 less than 0. But the left-hand side is not a single expression yet. So what do? Now, here's my technique. I will extend the fraction bar, but the moment I'll extend it, I need to multiply it with the denominator. So we will have x plus 2 extend minus 4, but multiply it with the denominator times x all over x less than 0. That's my technique. What is the proper way to do it? You multiply it all by the LCD so that you can have one single fraction. So we now have negative 4x plus x. That's negative 3x. Negative 3x plus 2 over x less than 0. That will be our starter, okay? A single expression on the left and 0 on the right. So now let's solve for the meaningful numbers, numerator and denominator. Let's start with the numerator. Negative 3x plus 2 equals 0. Do transposition. That's negative 3x equals negative 2. Divide it all by negative 3. So x is equal to 2/3. You now have a fraction. The other one, let's first have the denominator. X is equal to 0. That's it. Next, we substitute our meaningful numbers to the original. Again, substitute it to the original inequality. So we have 2/3 plus 2 over 2/3. I'll work on the left-hand side. You can use your calculator for this. The answer will be 8. 8 is less than 4. This is a false. Next, let's have our denominator. Let's substitute it. 0 plus 2 over 0. Check. I told you a while ago, the denominator is always false. Why? It makes the fraction undefined. It's so undefined, so it's still a false. False for the numerator and false for the denominator. It means we'll have 2 open circles. Our meaningful numbers are 0 and 2/3. Ma'am, do I need to arrange it? Yes. You could not place 2/3 on the left of 0 because it's a positive number. Let's have circles. The numerator is false, so 2/3 is an unshaded circle. The denominator 0 is still false, so 0 is still an unshaded circle. Remember 0 and 2/3. Let me draw again so it will be easier for us. 0 and 2/3. Sorry, it's too far, but let's imagine that way. So our first area is this one, before 0. The next is between 0 and 2/3. The last is after 2/3. So for before 0, we can have a test value of -1. Between, let's just have -3. It's easier on my part. Between 0 and 2/3, we can have 1/3. And after, we can have 1. Let's substitute it to the original inequality. Okay? We have -3 plus 2 over -3. That will be -1 over -3. 1/3 is less than 4. True. Between 1/3 plus 2 over 1/3, that will be 7. Less than 4, it's a false. For the after, we have 1. 1 plus 2 over 1. That's 3 over 1. That's 3 less than 4. It's a true. If we'll shade the areas with true, it will be before and after. So it will be our answer. I told you this is negative infinity and this is positive infinity. So we have from negative infinity to 0. We will have parentheses for infinities, open, unshaded, so parentheses. But there's another answer, the after, right? So you write U. That means union. Union from 2/3, we use parentheses for unshaded, and positive infinity. This is now the answer. Any questions? Now, I'll go to the problem. Actually, this is different. This is different from the one in the module, in the chat with the expert. But I'll have this one because it's almost the same with your quiz. Now, Maria can clean a room in 4 hours, while her sister can do it in 6 hours. If they work together, at least how many hours will it take them to clean the room? Now, the names we have Maria and the sister. Maria can clean the room in 4 hours. So in 1 hour, only 1/4 of the job is done. That's the rate. The sister can clean in 6 hours. So the rate is 1/6 of the job per hour. The time together is missing, so we write it as X. And remember, work is rate times time. We multiply the two. That will be X over 4 and X over 6. Let's write the inequality. Work by one plus work of the other is equal to 1. That should be. But the question is at least. At least is translated as greater than or equal to. If you have at most, that's less than or equal to. So for this one, let's have less than or equal to. We multiply all by the LCD of 24. So we now have, we could do it this way, 6x plus 4x equals 24. That's 10x. Divide both by 10. So our x is greater than or equal to 2.4 hours. Now, what is the correct answer for this? That will be 2.4 hours, bracket, comma, positive infinity. So they can work together. The shortest time is 2.4 hours, but they can go beyond that. Now, any questions before we end today?